Okay, so today is kind of like an additional little review day for the cumulative because we just did the R2s yesterday. You got them back just now, and you now know whether you're kind of on track to get a good grade or not. If you had on the cumulative test more than 2 wrong, then you should study more this weekend because the best you could get if you had 3 wrong is like a A minus, and that's if you really rocked the rest of the test, and they are not going to be easy. Here's one that's on the easier side. Let me think. Yeah, I think this is going to work. Remember that saying, if you can factor it, you should? It comes up a lot on this test. Would you please factor that one? No more obsessing about the problems that you got wrong on the R2s. You need to focus on these. Well, these practice problems we're going to do is going to help a lot if you do them with me. So once you factor this, make sure you factor it all the way. This is the test where you did the most factoring of your life. You had never factored so much. And you learned how to factor by grouping and factor strange things that had 5 terms in them using synthetic and long division. So this is the factoring test, along with a different one too. Okay, so hopefully you remembered you're going to group them like this, and then x squared comes out and you have x plus 4, and negative 4 comes out and you have x plus 4. And then, if I factor the x plus 4s to the front, I have x plus 4 and x squared minus 4. And then Mr. Server marks it wrong and cries a little bit because you were so close. What should you have done? Mr. S, did you factor it further? What did you get? What is the square root of 4, though? There you go. X plus 4, x plus 2, x minus 2. All right. Then, what if I asked, how many real roots did this polynomial have? What was it? 3 is correct. What was its lead coefficient? 1. The fact that it was positive 1 tells you which end is up. The right. The lead coefficient, if you see that one being positive, it's up on the right. How about the other end? Is it same or different? Different, because it's got a degree of 3. Was there any imaginary roots? No, there was 3 roots and they were all real. If this had been a plus, would it have had imaginary roots? Yes. All right. Good. Enough about that. Here's another one. Oh, sorry. Okay, and then last but not least, there. All right. This one is got a little bit of factoring, a little bit of dividing of fractions, and then when you're all done, you have a simplified answer, and I want you to tell me 3 things about it. Horizontal asymptotes, ask Bob. Vertical asymptotes, be careful because vertical asymptotes are right in there with the holes. And this one will have more than 1 hole. All right. I'm going to pause for a second. This would be the toughest question if it was on the test. So take your time, put it all together. You might be able to do the factoring and think, oh, this is easy. But then answering those horizontals and verticals and holes all correctly, this is tough. right, I'm going to pause while you try that one. Okay, let's see how you did on this one. First off, I'm going to make a little room for factoring these guys. Try to move it up a little bit. And then if you can factor it, you should. X plus 6, x minus 1, x plus 7, x minus 7. And I want to just take a moment to note that at the beginning of the year, you guys couldn't even close to have done this. A lot of you could barely factor, and you've gotten a lot better at it. So if you can do that, you just that's like 5 kinds of factoring, flipping and multiplying fractions. This is what the top 20 is all about. So if you're on top of your top 20, this should be like, that wasn't that hard. All right, now I'm going to cancel that and that. Ooh, that creates something, a hole. All right, and here's another one. That and that. Another one. So what's left is this equation. Y equals 7, don't forget the 7, times x plus 6. Some people say, didn't that 7 cancel over here? No, there wasn't a 7 on the bottom, so that never canceled. So it's still there. And then there's an x minus 7 on the bottom and an x plus 1 on the bottom. Those things, vertical asymptotes. What about the things that canceled? Holes. Never even asked you for those yet. Oh, wait, did I? Yeah, I did. Okay, there it is. And horizontals. Is this a bob, sob, or a bot? It's bigger on the bottom because if I multiplied it out, it'd be an x squared down there. So bobs are y equals zeros. Y equals 0 for that. X equals 7 and x equals negative 1 for that. And the holes, hardest part, I'd say. Holes we're at, well, let's do this one with the 7 here. Well, then negative 7 is the x of the hole. And how do I get the y of the hole? By plugging the negative 7 in here. What a pain. Yeah, I don't think they'd be this hard to find the holes on the test, but just because there's a lot of numbers to crunch here, but that's negative 1 times 7 is negative 7 over negative 14 times negative 6, positive 14 times 6, 60, 84. Okay. Whew. Hardcore. I'm impressed if you got that. Anybody actually pull off negative 7 84ths? Sweet. Can 7 go into 84?
112. Negative 112.
Wow, I'm even more impressed. Negative 7 comma negative 1. Apparently 7 goes in 84 12 times. Oh, I suppose. Look, 7 goes in here and twice, and then the 2 times 6 makes 12. So that actually makes some sense to me. All right, and how about this? Isn't there 2 more holes? No, there's 1 more hole. 1 more hole at 1. And I put a 1 here, and that should be easier. I put a 1 in here, and here, and here. And I have 49 on top. And on the bottom, I have negative 6 times 2, negative 12. Don't think it can be. I'm only seeing 7 going into the top, and that doesn't go into the bottom, so I'm pretty sure it can't simplify. Did anybody pull off negative 49 twelfths? Nice. That, if you try to get the average kid on the street, average anybody, average human on the street, only less than 1% of people could get that right. So, nice job. That was a really hard problem. Okay. What else do you have to know? So much stuff. All right, let's try this one. This function is increasing and decreasing at different times. It's decreasing from negative infinity until it hits 3. And then it starts decreasing again between 3 and infinity. It's increasing in that little zone between, wait, not 3, sorry. I'm going to say 8 and infinity. And it's increasing in that little zone between 3 and 8. Here's the thing you could be asked. There's actually a lot of things. They could ask, where is the local minimum? Where is the local maximum? I'll write all these things up. Local min, local max. What is the lead coefficient? As in, is it positive or negative? Not exactly what is it. And last but not least, what degree is it? And on that, we don't know exactly, but we could tell if it's odd or even. All right, I'm going to pause for a second. I'd make a sketch if I were you. It really helps, especially on the mins and maxes. Pausing. So just a quick check on this part. Did you have it decreasing until it hit 3, which is like there? Now, yours doesn't have to look exactly like mine, but it'll look kind of like mine. Increasing between 3 and 8, and then decreasing for the rest of the time. Be something like that. Could have been shifted up or down from that, but the main thing is you'd have found that the low spot, the local minimum, was there, but you got to be able to say where that is. And there would be the local maximum. So how do I say where the local minimum is? It's wherever you made your x equals 3. Like, I don't know how high, but yours would have to be on the line somewhere right there. Somewhere on that line is where you'd have to have your minimum. Your maximum was at this spot where it's 8. So at where x equals 8 is where the max would be. And then the local max. And then the last two parts, lead coefficient, since it's down on the right, it must be negative. And since these are going opposite directions, it must be odd. Raise your hand if you had all of those right. Okay, if you didn't, try to learn from your mistakes. All right, now on the R2s, you had a question kind of where there was a hole in the graph. Well, how is it going to be if it's an R3? Well, it must be a harder graph that has a hole in it. Instead of just a straight line with a hole in it. What if I, for instance, gave you an upside down parabola which had been shifted over 5 to the right and up 4, and had a hole at -2. You should be able to ignore the hole at first and just write the equation for the parabola. And then pop the hole into the equation. All right, I'm going to pause. We give that one a try. I was asked a good question. I didn't say whether there was a stretch factor or not, and so we're going to assume there is not a stretch factor. Okay, let's see. I hope you said parabola shifted right 5 and up 4. Notice that's how far right it is. I could easily see somebody messing up and replacing like the 5 and the 4, like switching them around. And then, do you get that it's upside down and it needed a negative? Who caught that? About half the class. All right. There's a negative because it's upside down. Then, what about the hole? There's the easy way and the hard way. The easy way is, if you just put parentheses around this, then you almost can't go wrong. You'll just put a hole in the top and the bottom, and something will cancel. Is there another way? Yes, but I would like it if you would always just put parentheses around that, and then you could put a hole in at x, let's see, it's a -2, so I need a +2. They're always the opposite of each other, right? And then x +2 up here. Is there another way? Yes, but this is the way I'd recommend, because the other way, it works too. I gotta move that 4 over to do this other way. And the +4 will go like way over here, so that I can squeeze in an x +2 over, and you got to be careful. If you extend that all the way underneath the 4, it wouldn't work. Like, all it would take is to extend this all the way, and then, nope, it doesn't work anymore. That's why I don't like this way, because if you're not careful with that denominator, if you have the, right, like if I extend this all the way out, then that x +2 wouldn't cancel. So I think that other way where you put a parenthesis around the original equation before you put the hole in, that's the safest way. So this way is correct, but I wouldn't try to do it that way. I would just take the one I had before. Here, I'll put it back up here. That with parentheses, and then put the hole in. There. Okay. Yes?
And if you don't put like a second parentheses around,
Yes, those missing parentheses would make it wrong. The reason is if I erase them right now, that x plus 2 would not be able to cancel.
why?
Good question. It would be like this. Would those x's be able to cancel? No, because the top isn't factored. So just take my advice. You don't have to, well, you can trust me, I'm not trying to hurt you. Put parentheses around it so that when you put the other parentheses up, it'll work. This way, these can cancel. All right, we got to go on. There's so many things to know. Next one is about heavy-duty factoring. I made this one up from scratch. Took me a while, but it worked. I checked it in my other classes. Now, would we be so cruel that we would say, I'm not telling you what goes into this, but it does factor? Yeah, we could be that cruel. And could you, though, use a calculator to figure out what the root was? Yes, and I'll save you the time. Let's not have you go take out your calculators and everything. It would just take too much time. If you did graph it, it would tell you one of the roots, but would it tell you all of the possible roots? Do you remember that FCON over FCO thing? Let's review it right now. So you've got this written down, right? This is called the rational root theorem, and it tells us what the possible roots are of this. We can know exactly which one is real by using a calculator and graphing it and seeing where it touches. But this, the factors of the constant, do you guys know that that one's called the constant? The factors of the constant are 1 and 5 and 3 and 15. I didn't put them in order, but you don't have to. And then the factors of the coefficient, the lead coefficient is just a 1. What's the factors of a 1? 1. And then don't forget plus and minus. It's really easy to forget that it could be positive or negative, all of those things. Now, dividing by 1 doesn't really do anything, so this is actually a pretty simple one. And I'm going to put a parenthesis around that, and there are my possible roots. It could be 1 or negative 1, 5 or negative 5, 3 or negative 3, and 15 or negative 15. But I'll be your calculator for you. Imagine for a moment I'm the calculator, and I graph that, and it looks like that. Let's say it looked like that. Which one do you think is actually the root? Negative 1. And I'll say it is officially negative 1. So everybody, right now, try to figure out if negative 1 goes into this, factor it. Hint, think synthetic. Negative 1 is a root. Yes? Because there's only a 1 in front. The lead coefficient is that one. All right. So use synthetic and factor this thing all the way. And that all the way thing is kind of key. You don't want to just factor it once. You want to factor it until you can't factor anymore. Answer, I hope you use synthetic. That's what I think the easy way would be. 1, 4, 8, 20, 15. Draw the line. Drop it like it's hot. Multiply. Add. Multiply, add, multiply, add, multiply, add 0 at the end. Yay, it worked. Raise your hand if you had that one right. Awesome. Now, that's what you had to do for the R2. So what makes this harder? Well, we have to go all the way. X plus 1 was one of the factors. And this really meant x to the third plus 3x squared plus 5x plus 15. And then keep on factoring. So I'm going to factor this. Could you stop with the bouncy ball? It's like having a cat sitting in the front row. All right, x squared, and then x plus 3, and then 5, and then x plus 3, and then the x plus 3 will factor out. And I had one kid say, but Mr. Server, I graphed it, and it touched at -1 and -3. Do you see why? Because look, that's why it actually touched at 2 places. All right, and then how about this last one? Is that a place where it touched? No, because those are imaginary roots. You can't see those. They're like leprechauns. You can't see them, but you know they're there. So how many roots did this have? 4. How many were real? 2. 2 were real, 2 were imaginary. How would I have known there was going to be 4 roots? Because look, it was to the 4th. That's called the fundamental theorem of algebra, roughly. All right. Did I factor it all the way? Yep, and I used factor by grouping. Some kids right here would have used synthetic again. They would have put that in the calculator, saw that it touched at -3, and they could have used synthetic right here. That would have been fine. You can double synthetic. If you looked on your key, you'll see that that happens in some of them on the key. They use synthetic twice. Okay, we're getting close, ladies and gentlemen, but we're not quite done yet. All right. The graphing. Imagine for a moment we've already factored it, and it came out to this after we factored it. And we go, oh, nothing canceled, so there's no holes. Wrong. Is there a hole? Clearly from my noise, there must be a hole. Where is it, sir? At x equals what? X equals 0. Because there is something that would cancel, and a lot of people don't see these as the same thing. If I write this x squared out as a x times x, maybe you'll see it a little better. That is a hole. Like the cat that keeps on pushing like things off the shelf. Anyways, 0, comma, and then if I put in the 0, it'll have a 0 on the bottom. What? So then is this an asymptote or is it a hole? It can't make a hole because it's 0, comma, it doesn't exist. So then this one is an asymptote. Okay, so there's an asymptote at 0. Asymptote 0 at x equals 0. How about the horizontal asymptote? That's the bob kind. Is this a bob, sob, or a bot? It's a bob because it's bigger on the bottom. It's x to the 3rd on the bottom. Or if we do it before things cancel, it's an x to the 4th on the bottom and only an x to the 2nd on the top. It's definitely a bob. What's the rule for bobs? Y equals 0. It's on the outside and it's 0. And so then there's an asymptote there. So we got both the asymptotes in there. How about the hole? The hole wasn't really a hole. It was actually an asymptote. All right. Then, if I had to graph this, I'd like to know if the points are like up in there so I can do this. Or if the points are like down in here so I can do this. I got to figure out where they are. So let's pick one point that's bigger than 0 and one point that's less than 0. So when I pick 1, everybody please put in 1 and -1 and see what you get. If you can't find 2 points, then you won't be able to get the credit for the graph. I'll pause for a second while you find 2 points on this XY chart. Okay, I'm putting in a 1. And this is already canceled. That's important to know. All right, now really, if I put a 1 and a 1 on the top and the bottom, it's not going to change anything. All right, a 1 goes in here, and here, and here, and here. So then that's -2 over -6 times 7 is -42. Cancels. 2/42 is 1 over 21. Basically, a really small decimal. So 1 comma a really small decimal. So that's like, oh wait, not a negative number. Positive number. There, it's up there. That's all I really needed to know. Now I can just assume it's going to go like this. Do I know exactly for sure? No, but I'd have to get a whole bunch of points. Oh, did I make a mistake? I see people looking around. Uh-oh. Okay, double checking. I got a would you agree with -2 on the top? Was I okay there? Yeah. And then 6 times, why is this not 6? Isn't that 6? Oh, 9 times 6 is 54. Okay, fine. So, 2 over 54, also a very small decimal, still up here. Now let's put in -1. When I put in the -1, -1 goes here, 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 and here. And that's -4 on top over, let's see, -1 times -8 times +7, 56, let me think, +56. Do you guys agree with +56 on the bottom? And therefore my final answer is negative. All right, so it's a small negative number. That means it's down here. That means it generally looks like that. Yay. Just relax. I'm not leaving yet. You have to be ready 2.5 minutes early. Bus won't leave without you. Okay, so what would I do if I were you getting ready for this test? I would go and look through. First of all, I take the rest of the day off. You just did a lot of math. I saw you. You were working with me. That's good. But tomorrow or the next day, I would take some time and look through the R3s. And then it totally depends. Are you on track for the A and feeling really confident? Then you don't need to do many R3s. If you just got 3 or 4 or 5 wrong, then dang, you need an amazing performance on Monday. So I'd go through and do a whole bunch of R3s off that sheet that's called R3 Extra Practice. What do you actually have to turn in? That review worksheet that's at the very top that we've been working on for like 3 different days. That review worksheet where we did half of it one day and another half of it the other day, that one's already been due for a while, but I haven't actually had you turn it in yet. That's the only thing you have to turn in. There's a thing called cumulative review worksheet. All right, any other questions? Yes. I know, I'm telling, because if people are absent, then people are absent need to know what the homework is. So, okay, then, that's all I have for you for today. Congratulations, you made it through a long week.